Today in Algebra 2, Chapter 5, Section 2, we are going to break this lesson down into two parts. This is part 1, where we will be evaluating polynomial functions. A polynomial, poly meaning many, okay, is a monomial or a sum of monomials. Mono meaning one, okay. We're going to put a sum of several one terms together. Okay, in order for a polynomial to be a function, there are two rules. Number 1, x cannot be in the denominator anywhere. And number 2, the exponents must be whole numbers. We can't have variables as an exponent, we can't have decimals, we can't have negative numbers. They must be whole numbers. There are 3 definitions that we need to be familiar with before we go further with these polynomial functions. The first one is standard form. In order for an equation or an expression to be written in standard form, it has to be written in descending order from the greatest exponent down to the smallest. The degree of a polynomial function is the highest exponent in all of the terms. And the leading coefficient is the coefficient of the term that has the highest exponent. Let's take a look at this expression, x to the 4th minus 1/4 x squared plus 3. We need to determine if that is a polynomial function, and the answer to that is yes, it meets both of the rules. Okay, the second thing we need to decide is it in standard form? Standard form, it's written from the highest exponent to the smallest. So here we have the highest exponent is 4, and then it goes to 2, and then you don't have any, so we're good there. So yes, it is in standard form. The degree is the highest exponent, which is 4, so this is a 4th degree. And the leading coefficient is the coefficient of the term that has the highest exponent, and that is 1, so our leading coefficient here is 1. Here is a second expression, 7x minus the square root of 3 plus pi x squared. Is this written in standard form? Well, no, it's not. Okay, so let's put it in standard form. Okay, our highest exponent that we see here is 2, so that term has to go first. Pi x squared. Then we can put plus 7x, because that's the next highest, it's to the 1, and then minus the square root of 3. Is this a polynomial? Yes, it is. It meets both rules of our polynomial function rulebook. What is the degree? Okay, the degree is the highest exponent, and that is 2, so we just turned this into standard form, so we're good there. The degree is 2 because that's the highest exponent, and the coefficient of the term that has the highest exponent is pi, so our leading coefficient is pi. Our third example is an expression that has 5x squared plus 3x to the negative 1 minus x. Is this a polynomial function? The answer to that is no, it is not, because it has an exponent that is not a whole number. We cannot have an exponent of negative 1. That will not work, so none of the rest of this matters. If it's not a polynomial function, we can't do the rest of it, so no, that is not a polynomial function. Our last example for this page is x plus 2 raised to the x minus 0.6 x to the 5th. Is this a polynomial function? The answer to that is no, because we have x as an exponent, and we don't know what that is. That could be a whole number, but we don't know that it will be. So therefore, this cannot be a polynomial function, so we don't need to go any further with it. Now we are going to look at evaluating polynomial functions. With this function, f of x equals 2x to the 4th minus 5x cubed minus 4x plus 8, the directions say to evaluate when x equals 3. We will do that first by direct substitution, which means that we will take f of x equals 2, and every place that there's an x, we're going to put in 3, so that's 3 raised to the 4th minus 5 times 3 to the 3rd minus 4 times 3 plus 8. You can put that straight in your calculator and get the answer, and when you do that, you will find that f of 3, because we are doing direct substitution, f of 3 equals 23, which means that when x is 3, y is 23. That is your answer. The second way to evaluate this polynomial when x equals 3 is to do synthetic substitution or synthetic division. To do that, we will take the coefficients of this polynomial, 2, -5, 4, and 8, and do what we call synthetic division, synthetic substitution. So we are going to take those coefficients, 2, and then we're going to use -5. Okay, now there's a problem because they skip the x squared term right here. It has x to the 4th, it has x to the 3rd, and then it skips the x squared. So you have to put a 0 in for that x squared to be the placeholder. And then we'll have -4 and 8. And those are all the coefficients of our x terms. Right, now we're going to draw a little bar, something like this. And we're going to put a 3 out here. And this is called synthetic substitution or synthetic division. The first step is to take your first term and bring it straight down. So your 2 comes down. Now you take your 3 times 2 and you put the product in the next column. Then you add those two numbers in that column together. -5 plus 6 is 1. Once you have another number below the bar, you will multiply that by this original number. So 3 times 1 is 3, so that goes in the next column. You add those two numbers in that column together. 0 plus 3 is 3. Again, we take this 3, our original 3, and multiply it by the sum here. 3 times 3 is 9. Put that in the next column. Take that sum, -4 plus 9 is 5. 3 times 5 is 15. 8 plus 15 is 23. And that is your answer, just the same as what you did right here. Here we did, in the first way, we did direct substitution. The second way, we did synthetic substitution. Either way will give you the correct answer. The assignment for 5.2 Part 1 is going to be 3 through 21, the multiples of 3. You'll have a good day.